All right, so I don't have an answer for how to get color working in VI on Sigwin, but do some Googling and send me some questions. If you're trying to get the arrow keys and backspace and all of that stuff to work, okay, so that's posted on the website. But I don't know how to get the color because I always spend my time trying to turn the color off. So, but if you find some stuff, I can help you with questions on that. So yeah, SLP is coming up, and everybody's been working really hard on their SLPs, right? So so your final report is uploaded on the 26th, and the presentation is that last Tuesday. So your upload is a one-page poster. So download this form and fill it in. Cut off the second page. The second page is the instructions. So here's what it looks like, right? So don't leave your project title, okay? Fill the stuff in. So name your project date, people who are on your team, and this can be one per group, okay? As long as everybody's name is on there. Only one person should turn it in. So you don't have to do this exactly, but these are basically the things that you can think about discussing. So problem definition, right? What's the problem that you're working on? Problem statement, scope, timeline, things like that. Research analysis, so we've probably spent part of this quarter digging into this problem, trying to see what other people are doing, trying to decide what you're going to do, what the advantages are, and so on and so forth. And then a discussion of your current plan for how you're going to do whatever it is you're doing, right? Discussion of applications, whatever else you think makes sense in here. We try to stick to this layout, right? Colors and style and stuff like that, just for a uniform appearance. But if there's other things you want to put in here, feel free to add or modify sections. But the goal is to have basically a one-page poster that is a synopsis of the current state of your project. So again, usually first quarter, the goal is really pinning down what exactly you're going to work on. So you start with an idea, you do some research into it, you find out what the impediments are, you find variations on the idea that are more interesting to you, and so on and so forth. And so hopefully around this time, you've started to get a pretty solid idea what it is you want to work on. And then in winter and spring, you continue working and actually doing the development. Hopefully end of spring, you've got some kind of prototype. So this is sort of the first phase of that, and it's really about finding and refining your problem. So fill this in, cut off the second page, right, because it's just instructions. Save it as a PDF, upload it to Canvas by the due date, due time. And then I'll take all of these, they get sent to the printer, and on the day of the presentation you can pick up your posters and they're printed out like 11 by 17 or something. They're like the ones in the hallway, and those are available for you to take and use.
And presentations are on what day?
So presentations are the last Tuesday of the term, so December 4th. All right, so your original proposal was 25 points. This upload, this PDF is worth 50 points, and then coming to the presentation is worth 25.
So a total of 100.
Total of 100 points. And then at the presentation, we can talk more about this. But at the presentation, there'll be these yellow sheets with 25 lines on it. And during quiet times, as things start to die down, or if you have multiple people at your station, you can take turns. You go around and you look at other people's presentations, okay, see what they're doing, talk to them about it. And then after you visited somebody else, they can sign off on this signature sheet. And if you get 25 signatures on that, you get 10 extra credit points on the SLP. So 110 out of 100. So we'll talk more about that closer to the date. Yeah.
Under the last thing, potential applications for a game, it would just be in entertainment value.
Yeah. But you can spin it however you like, right? So what's the service? Well, students spend a lot of time studying, and it's very stressful, and they need to be able to relax in order to be more successful in their classes the next day. So this gives them an opportunity to do that or whatever. Yeah.
Can we put visual elements into this?
Sure, absolutely. Yeah, you can put in pictures, schematics, diagrams, charts, whatever you like. Like I say, we just try to stick to basically, you know, color scheme and title at the top and logo on the bottom and stuff like that. Occasionally somebody will turn in a 10-page PDF document or something, and it's like we don't really want to print that out on 10 sheets of cardboard. So, all right, so again, one of these per group, okay? And make sure everybody's name is on it so that everybody gets credit for it. Does that make sense? Okay. So while we're here, what else is coming up? So PA5 is due a week from Friday. And that's kind of it until the final exam. So, oh no, and you got a lab, sorry. Your lab is due Friday, is that correct? Oh, it's a week from Friday. Wow, I gave you a lot of time for that. Yeah. Okay.
Well,
So you got.
I appreciate it. I'm gonna go Black Friday shopping. I don't want to be doing the lab.
Well, that's the way to kill time till midnight, right? Yeah, cool. All right, so any other questions?
Do you play Warcraft?
I don't. I probably should. The last video game I really got sucked into was Skyrim and Fallout. So.
Pretty much.
Yeah, a little bit. In my spare time, right? All right, so let's talk about sed and awk. Let's start with. It's actually gawk, but originally it's awk. Let's start with awk because
This
it's kind of more fun. Bless you. So side note on Zenity, we some students and I have officially gotten Zenity working under the latest Sigwin, and it does work. So that's doable. And I don't know if anybody's gotten it working under Bash from the Windows Store. That still needs to be figured out. It definitely does not work from the Linux server, although you can probably make it work at home, but you're not going to make it work at Clark because of their firewalls. Yeah?
I like when they're trying to get it to work on the Windows subsystem for
Mhm.
Windows, and it requires you have to, just the base start of it is removing the open SSH that comes with the subsystem and reinstalling it to get the full access to it. And
Really?
then it goes into a whole third-party
Okay.
Windows server and changing your ports. And it's a
Yeah.
nightmare.
Okay. That's kind of what I thought.
Yeah, probably better just find someone with a Mac or Linux machine.
Yeah, or run VirtualBox and install Linux under VirtualBox. Right. So VirtualBox is I keep talking around this, but VirtualBox, right? It's free software. It runs under Windows, and it basically gives you a pretend machine, right? An x86 based machine, and on that pretend machine, you can install Linux. Right, so you get the standard Linux distro, and you just say, this is my CD, and you install it, and it runs a whole virtual machine inside your Windows system, right? It doesn't replace it, you don't have to reboot, it's just a program, but it's virtualizing a whole x86 machine that you can boot up as a Linux box. And I'm pretty sure Zenity will work under that, although I haven't actually tried it. But that's a nice clean option to get Linux running under Windows. All right, so let's talk about awk, because awk's fun, and it's Friday, so we should do fun things. So here's the general format of using Gawk. The command name Gawk followed by a program followed by a file. Okay, so Gawk is a file processing tool, and based on the program that you specify, it does various things to the contents of this file. Okay, it generally doesn't change the file. It reads from the file and produces output to standard out. But that transformation from what it reads to what it produces is controlled by this program. And we can also, if we don't want to type a bunch of commands, we can say awk-f and put in the name of a program file, right, a text file that contains a program, and then the file we want to process. If we don't do this, then we actually put the whole program right here as the second argument, so we throw it inside single quotes usually. So what does a program look like for Gawk? So a program is basically some sort of pattern, and then inside curly brackets, some list of actions that we want to perform if that pattern matches what we just saw in the file. And a pattern could be a regular expression. So it could be a regular expression. Or it could be a keyword like begin or end. And begin is just a special pattern that always matches in the beginning of a file, end always matches at the end of a file. And in these patterns we can use variables like $1, $2 to correspond to columns in this input file. And I'm going to give you a million examples which will make this clearer. We can also talk about the file name. We can talk about the number of fields in a particular line. We can talk about the number of records that we've read, and various other things. And we can use things like double equals and so on and so forth. Well, let's do some examples. All right, so I'm going to play with a foods file here. So I have a generic file of foods. There's basically a name of a food, the type of the food, the color of the food, and whether it's cheap or non-cheap to buy. So it's just a test file we can play around with. Say what? Because no one knows what hot dogs really are.
That's unnerving.
Yeah.
It has liquid and it has meat.
Yeah. I have a friend, he wants to make a brand of hot dogs, and his tagline is going to be fewer snouts.
Okay.
So, so let's look at a sample program. Length parentheses $1 is less than 5. Okay, so as we process a file like this, $1 is going to correspond to that first entry. Okay, everything's space separated. So $1 is going to be the name of the food. $2 will be the type. 3 will be the color, and so on. So if we say length parentheses $1 less than 5, that's a pattern which should pick up kiwi and Coke and Spam, right? But not mango or hot dog or burger, right? So I'm asking for the length of the name of the food to be fewer than 5 characters. And so this is going to be a program.
Spam is on the piece?
Yeah. That should be unknown also, I assume. Yeah, okay. And it's pink.
Pink and cheap.
Pink and cheap. All right, so so this is a program, and for an action, I'm going to say let's just print $0. So kind of like in Bash, $0 means $1 followed by $2 followed by $3. It's the entire line. Okay, so $1, 2, 3 is the first, second, third field. $0 is the entire collection of fields. So the whole line.
Do you need spaces in your file in the program?
I don't know. We'll find out. Apparently. All right, so here is my awk line. So if length of field 1 is less than 5, my command is print $0, which is the entire line. So there's my lines where the first field has fewer than 5 characters. So let's see if we need a space there. I'm going to guess no. Yeah, we don't. So if I were to print $1, I would just get a list of the names of each food that satisfies this criteria, like that. And if I were to just print $1, $2, it'll just show me the name and the type of item it is.
All in one.
And they're all pushed next to each other. So I could put a space in between. Or I think you can also do a comma maybe, and it'll automatically throw spaces in there.
It might be the better thing.
Might be, but then you got to remember commas. All right, so let's make a program in a file. So here's the program we just did. If the length of the first field is less than 5, let's print out the field. Let's also print a header. So I'm going to use the special pattern begin, and begin will match before we actually read anything in from the file. So it's a way to do initialization. So I'm going to say at the beginning, print short foods. So I'm going to print a header, basically. So this is a file called F. So I'm going to say awk-file name F. I'm going to run this on foods. And so I've got a little header printed out now. And I could also print a pattern end. And the end pattern matches when you're done reading from the input file. So at the very end, this pattern should match, and this should print out goodbye. All right, so now I get a goodbye message at the end. And the order in which I write these things in my program doesn't really make any difference. because basically what it's doing, it's opening the file, it's going to read in line by line, and at each point it's going to check to see if what it just read in matches this pattern. And if it does, then it will go ahead and apply this action, right?
Does it only apply to first pattern it finds?
No, it'll keep going. So let's throw another one down here. What are our foods here? I don't know. I'll pretend I like fruit. Let's see if that works. Alright, so every time it reads a line and it finds that the type is a fruit, it prints out yummy.
They print out yummy for spam.
Well, it didn't print out, so let's because this first one is stopping it from printing out $0. So it was actually doing yummy for the mango, and it was doing yummy for the kiwi and the banana and the apple. But since we were only printing out things with a length less than 5, it wasn't printing out the mango and such. So it looked like spam was yummy. Maybe the computer knows something, I don't know.
Depends on how you cook it.
Yeah. All right, so we can write programs to do some of these things. So so here's another program. So there's a begin, which is going to print out a header, and then there's no pattern specified for this instruction, right? So if you don't specify a pattern, it automatically matches every single record. And here I'm trying to print out NR, which is the number of the record, followed by a space, followed by $0. So if I run this program, right, I get my original file, but I've thrown line numbers in the beginning now. So that can be an easy way to number your file lines. All right, so there's another kind of pattern we can do. So we can specify a pattern which is two conditions separated by a comma. And here's the idea. Basically, when this pattern matches, it begins processing those lines from your file until this condition is satisfied, and then it stops. And then if this condition is satisfied later, it will start treating your input as if it matches your pattern until this condition is satisfied, and then it will stop. And so a kind of typical way to do this might be something like number of record equals 3, comma, number of record equals 6. And this would basically print out the lines of our file between lines 3 and 6. So here's another program. We're going to start matching when we get to record 3. We're going to stop matching after record 6, and our action is going to be to print out the record number or colon and then the entire input line. And so if we run this program, we get lines 3 through 6 of our file. We can also do a field, and we can say tilde slash and put in a regular expression. And so we can match fields contents with regular expressions. So for example, I could say awk $1 tilde/O. So this should match any field where the name of the food contains an O. And if it matches that pattern, it should print out the entire field on the foods file. So there's our all foods that begin with, or that have an O in them. And if we search for carrot O, it'll give us foods that begin with the letter O. If we search for carrot ... $, what's that going to give us?
4 characters at the beginning.
Mm-hmm. Followed by the end of the field. So things that are exactly 4 characters. So same thing as if we said length equals, but using a regular expression. All right, making some sense? It's definitely quirky, right? But here's the main thing I do with awk, right? Suppose I want to print my input file, but I want to switch around the first 2 fields, right? So I could say awk print $2, $1, $3, $4 foods. Right, so now I'm printing the second field followed by the first, and then the third and the fourth. Or if I just want to know what all the different colors of my foods are, I could just print $3. And if I sort that, I get a nice sorted list, and I can look at that and I can say, well, I got 1 brown food, 1 clear, 4 dark, 2 green, right? But I could pipe this into unique -C, which says count how many times each line occurs, and it will give me a nice synopsis. And I could take that and I could pipe it back into sort, and what I can't see. Forgot the bar. Right, and so now I've got an increasing list of how many times each color of food appears. So yellow and dark are my most popular, and brown and clear and orange are the least, right? How often do you have to do this? Surprisingly, I have to do this fairly often in my life. I don't know if that's a problem. But I'm constantly like taking data in this kind of form and needing to crunch it down into some other form, right? Like perhaps this. And awk and sed and unique and sort and sometimes word count and lots of pipes let you do like just a phenomenal number of things. It's one of those things that if you don't need it, it's kind of like, well, okay, I guess that's cool. But if you need it, then it's like really, really useful. All right, well, we can go crazier. So here's something that starts to look more like a program. I have a begin block, which matches before I start ingesting from the file, and here I'm setting 2 variables equal to 0, cheap and expensive. And then any time that this 4th field matches the pattern cheap, right, I'm going to increment my variable called cheap, and anytime it matches the string spendy, I'm going to increment my variable called expensive. And then at the end of all my input, I'm going to print out 2 lines, and I'm using printfs here, and I'm going to print out cheap foods and the value of cheap, and expensive foods and the value of expensive. And if I run this program, right, it gives me a little synopsis of my data. Fairly painful to write a C program to do that. Right, you got to read in, you got to break things up by spaces, maybe use scanf or something, do some string compares, keep some tallies, detect end of file, and then do your prints. And it's, 12 lines in awk, including spaces and prettying it up. All right. Well, let's go crazier. So here's a 4-line program. Let me show you what it does, and then we'll see how it does it. So this tallies how many different types of foods I have in my list. 1 meat, 2 vegetables, 5 drinks, etc. And it's like, a 1 or 2 line program, right? So what's happening in here? There's really one action which executes on each input file. It says foods bracket $2++. Okay, so let's break that down. Foods bracket $2++. And our input field is something like apple, fruit, red, cheap. So $2 is the type of food. So on our first input, this is saying foods bracket fruit ++. And then there's like a burger and meat and something. And so our second file is going to say foods bracket meat ++. And then our third field might be banana, fruit, blah, blah. And so this is going to say foods bracket fruit ++. So what's going on here? What does foods bracket fruit, foods bracket meat mean?
Sounds like it's creating an array.
It's creating an array. This is an associative array. Okay, we touched on these yesterday from Bash. Awk understands associative arrays. So we're creating an array called foods, and it can be indexed by whatever we want. So here we're indexing it with the string fruit. Here we're indexing it with the string meat. And we'll index it with the string cookie or whatever the type of food is. And the first time that we try to access foods bracket fruit, it's a new entry in our array. It's initialized to 0 by default. So when we say increment, that basically sets foods bracket fruit to be equal to 1. When we do this, it sets foods bracket meat to be 1. When we do this, it will increment foods bracket fruit from 1 to 2. And so foods bracket fruit records the number of times we've seen a line of input where that second field was equal to fruit. So it's counting how many times that type of line occurs. And when we're done, this foods array has a different entry for each type of food, and the value of that entry is the number of times we've seen a food with that type. So it's tallying up our foods for us. And then at the end of our file, we execute this one line. So this is a for loop for food type in food. So that's how we iterate over an associative array's non-zero entries. So food type would first be equal to fruit, and then it'll be equal to meat, and then cookie, or some order, right? But each thing that's in our array. And for each of those food types, we print out number of %s : %d. Well, %s is the type of food, and the %d is that entry from our foods array. And when that runs, you get this nice output like this. Where? So food type's coming out in the first column, right? That's the %s. And then the count is that entry from the foods array. Oh, right here. Yeah. Yeah, so know, I could have done this. All right, so it's just whatever variable name you want. And yeah, nothing really has to be defined ahead of time or declared as far as variables and stuff go in this. It figures it out on the fly, kind of like Bash. Same way, it's sort of dynamically typed. Yeah, so this is potentially pretty cool. So here's a slightly different version. It's exactly the same except for this first line, and here, instead of doing foods bracket $2, I'm doing foods bracket $2 dash $3. So I'm taking the type of food, putting a dash at the end, and then putting in the color of the food, and that's what I'm using for the index in my foods array. So if I run this, it tallies up my foods in terms of type dash color. So I've got 2 unknown pink foods, right? Hot dogs and Spam, 2 dark drinks, and 2 yellow fruits, and 1 of everything else. So there's kind of a recurring theme here, right? These tools are really, really powerful, but they don't do anything except what you tell them to do. And you're hobbled not by the tools, but by sort of figuring out how you want to use them, right? If you understand the tool well, you can figure out how to write something like this program here on the left to get it to do whatever it is you want to do, but you've got to be able to figure that out, right? And that's practice. If you're in a state where you're doing lots of file processing, you start playing around, spending more time with awk or sed, right? Then you start to develop this ability to come up with programs to tell it what to do. If you're not in that kind of space, right, you're probably not going to do this. That's okay, right? Except for tests. But it's kind of like, you know, on a need to do basis. All right, here's something else we can do. We can replace the values of fields. So here I've got a program. I'm not matching any patterns, so this actions will fire on every input record. So first I'm going to print out the input field, and then I'm going to say set $1 equal to an X, then I'm going to print the input line again. And this is just going to, you know, replicate each record, but it's going to change the name of the food to X. I don't know why you'd want to do that. But you could put in a pattern like if the name matches this, then let's change it to that. And so on as well. What should we pick on? Gatorade. Let's try that. So if first field is Gatorade, we'll change the name to Powerade. I knew I'd get into trouble.
It's going to say Powerade 8.
Say again?
It's going to say Powerade 8 because you matched Gator, not Gatorade.
But I'm going to replace the entire first field with Powerade.
Oh.
Is it because you're inside the brackets?
I'm inside the brackets, yeah. file anyway. That's what happens when you try to write awk without notes. There we go. All right, so look at an index program. So here I have no pattern, so this is going to fire on every input record. And here I have a for loop, and I'm going for item equals 1, item is less than or equal to NF. NF is the number of fields on the current input record. So if you got blah, 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 NF will be equal to 4. Okay. So for each item on my current line, I'm going to increment count bracket $item. So if item is equal to 1, $1 is the first field. If item equals 2, $item is $2, that's the second field. So I'm incrementing an associative array indexed by each field on each record. And then at the very end, I'm going to do my usual for loop. I'm going to go through everything in my associative array and print out the number of times that it occurs. So what have I got? Well, I've got a word index program. Unfortunately, I put each word in twice. Right. So there's a word index program. Basically, each line of my input, I'm going through, I'm grabbing each word, and I'm bumping up a counter that tells me how many times that word occurs. So I can run this on War and Peace. And it tells me how many times each word occurs in War and Peace. And if I do a sort in numeric order, it'll give me a word index in increasing order. So the is the most common word, not surprising. All right. So there's a good chunk of PA4 written in awk. Right, that right there is reason enough to want to know more. So here's the same thing, except I've put a shebang in the top, which points to user bin awk-f. And I've called this thing index, and hopefully I've made it executable. And so now I can say something like index War and Peace, and it runs awk because that's what the shebang is, and the -f says this is the program, and it reads in from whatever file name I gave, and it does a word index.
Do the associated rows preserve order?
No. So when you pull the things out with this for loop, the order is effectively random because it's turning it into a hash, and then it's going through in probably hash index order. All right. Oh, we got 60 seconds left. I got so much more I could tell you. So here's an awk program that, what's it do? It prints out the numbers 0 through 9. Right? It's just a for loop. Here's a for loop that adds to a running sum. So this adds the numbers from 0 through 10 and prints out their sum. So there's 55. I'll leave you with this one. So this generates prime numbers from 3 to 1,000. And it's just your standard loop that looks for divisors, and if it finds a divisor, it sets the composite flag to be true, and at the end of the loop, if composite is 0, it prints out the number, and if you run that, there's a list of prime numbers. So awk is a whole little programming environment in itself, right? We can use it for pattern matching and pulling things out of a file field by field. But you can also do other things like generate prime numbers. So, all right. So we'll talk about SED next week and whatever else we need to go over. And